The basic idea behind use of semiconducting devices is to bring dynamic nature to electronic circuits because semiconducting devices are active elements. PN junction diode is one such active element which is used for dozens of applications. In PN junction diode, the two halves of same semiconducting chip is doped with P-type and N-type elements. The P-type side has excess number of holes, whereas the N side has excess number of free electrons. Now, since the P side has majority charge carrier as holes, so these holes diffuse to the right hand side to the N side and free electrons diffuse from N side to P side. This diffusion is like diffusion of gases, and as a result, in the central region of the junction, majority of holes and free electrons recombine with each other, giving rise to depletion region, which is of width of micrometer. Now, the diffusion of holes and free electrons causes charge imbalance and leads to development of polarity on the two sides, because the free electrons which drifted to P side or the holes which diffused to N side carried their respective charges, leading to positive and negative charge on the two sides. This polarity builds an electric field in the region, and accordingly a potential difference is set with N side being at higher potential and P side at lower potential. This potential is known as barrier potential. The value of barrier potential for silicon is of order 0.7 volt and for germanium it is around 0.3 volt. Now the diffusion of holes from P side to N side gets difficult. Simultaneously, diffusion of free electrons to P side also becomes difficult because this barrier potential won't allow them. But still, few energetic holes and electrons are able to cross over to respective sides, giving rise to diffusion current from left to right, that is in the direction of movement of holes. In the depletion region, which is full of bonded electrons, few of the bonds break, giving rise to holes and free electrons. This electric field now shifts the holes to the P side because holes behave like positive charge and will drift in the direction of electric field, whereas the free electrons drifts in the direction opposite to the electric field. So the drift is opposite to the diffusion, hence a drift current is set in reverse direction. So in PN junction we have the two currents, one is diffusion and other is drift. When the PN junction is not connected to external source, the diffusion and drift current are equal in magnitude and are always in equilibrium. But when they are connected to an external voltage source, say one side is positive and the other is made negative, so this will lead to increase in diffusion current and suppression of drift current. Whereas when you have positive terminal of the battery connected to N side and negative terminal connected to P side, this enhances the drift current and suppresses the diffusion current. That is, the flow of current on the two sides are different in nature. One is due to diffusion current and the other is due to drift current. This brings dynamism to such devices, and these currents can be controlled by use of various factors, hence leading to many applications. Popular application of diffusion current based devices are rectifier, light emitting diode, whereas the drift current leads to applications like Zener diode and solar cells. Thank you.